So today we're going to talk about time series analysis quite a bit. It is one of my most favorite topics. I have a couple of favorite topics in data analysis in general. Time series is one of them. For reasons I'll explain later. We still have people actively joining us. So before we actually move to the webinar, because it is a minute after 7 Moscow time, so it's time to start. And I appreciate everyone who is here on time. As usual, of course, I start with a question. And typically this question is somewhat related to the topic. Today's question is off topic, and it sounds like this. How do you stand out as a data scientist? Now, I didn't plan to bring this question up. It showed up in my Quora's digest, which I get about once every few days. I don't even know how this Quora digest ended up in my mailbox at one point in time. I sign up for so many different websites, and then my mail is full of junk. But occasionally, there are good questions that I would love to find answers to. So, of course, being the academic supervisor of a master's program that has to do at least partially with data science, it was immediately taken by this question. I followed it, and I saw what this John Wayland, senior manager data science at Florida Blue, had to say. So I have a question for you. While we're still waiting for our audience, because people are coming up, it's an important question. How do you stand out as a data scientist? Do you have any ideas? Please share them with us. Norris, no way. Oh my gosh, you are here. Well, I have to introduce you to someone very special. Norris Kruger was my MBA professor. Norris, who won't tell anyone how many years ago. An amazing scientist, one of the, I would say, founders of entrepreneurship as a field, because entrepreneurship was a part of strategy. And he was our class professor, and he was our supervisor when our team won the Northwest Venture Championship Forum in the year, well, we'll say this, okay, in the year 2000. So Norris was the one who actually was one of the people who introduced me to the good academia and how you're supposed to do good research and combine research with practice. Because in addition to being a professor, he consulted a lot with many different companies. So I am delighted to have you with us, and hopefully you will answer some of the questions about how do you stand out as a data scientist. So anyone, how do you stand out? Oh, I'm so excited. My former professor is here. Now I'm going to be so nervous.
Actually, I can allow him to speak if you don't mind.
Of course, no worries. Yes. Oh my gosh, your voice didn't change a bit.
Well, it was a while, a few years ago when you were in the class, but we were only 10 years old, so it really doesn't matter.
That's right.
One of the things that, let me brag on you, is that there are people who have trouble. They can do research, they can be very academic, they can be very practical, but they can't do both. And that's one thing that you, in fact, your whole team was really was pretty marvelous at, and you've certainly gone on to many great things. And now it's come, I won't say full circle, but pretty close, is that things like that, an awful lot of people doing academic research who are not as good at data science as they think they are. They know how to use it. Here is a tool I know how to use. I can plug in and say, well, I just throw some numbers into some spectral equation modeling and hit a button, and then voila. The reality is that you have to understand what the great questions are. What is the question you're really trying to answer?
Absolutely.
And one of the things why I've become a big fan of your school is that it's not really a new tool, but it's sort of new to the entrepreneurship world, is social network analysis. 20 years, 15 years ago, the math was so horrible that even God couldn't do the math. And now it's there are all sorts of powerful software, and we're finding some remarkable things with what is to you probably a pretty boring social network analysis, but finding out one of the more striking studies comes out of the University of North Carolina, Ted Zoller and Marianne Feldman, is what happens to the social network when you plug someone in whose job it is to encourage connecting. Well, the Connect superconnector she did a lot of connecting. What was interesting is elsewhere in the network, even people that the new player never touched, they started connecting more. Like there was this contagion, there was this modeling effect, which
Absolutely.
is bloody marvelous. And we would have never found it without the right tools. But we also wouldn't have found it if Ted and Marianne hadn't asked the right question to answer that. So, and of course, when I look at data science and I see what they're getting paid in Silicon Valley, I do wonder if I'm in the wrong field. Someone with a 2.0 grade point in data science can start at 200,000 a year. Anyway, I love what you guys have been doing, and I don't want to derail your presentation here, but I'm here to learn, Dalia. I'm here to learn.
Thank you, Norris.
Madam Meisberg.
Well, I never thought that I would hear that from one of my greatest professors, that they want to learn from me. But thank you for being here.
You can learn. You can learn from everyone, and that just means you have. Some people, it's hard to learn. It's hard to learn from them, but you are easy to learn from, because you two always ask not just good questions, but the great ones.
Thank you, Norris. You know what? I could not have planned it this way, because I really wanted to ask a question of what is a data scientist anyway, coming from that core question, because data science is such a hyped up field that people go just for the title without really realizing what it is about. And the term data science traces back to 1974, because it was actually the Danish computer user who wanted to have a different name for engineering science. At that point, there was no computer sciences definition. So they come up with the term data science. And then, of course, it was used interchangeably with computer science. So a lot of people who are true data scientists in its purest form are just computer programmers. I mean, I don't want it to sound as computer programming as in some way subpar to anything, not at all. But lots of people look at data science in an expanded way, because Harvard Business Review in its famous article called it the sexiest job of the 21st century. So data science is now a buzzword that leads many people astray. It's applied to many different fields, sometimes not related to too much together. For example, business analytics is not a whole lot about computer science. It's not a whole lot about programming. It's analyzing business, its efficiency, its effectiveness. And by the way, there is a difference, as Norris knows very well. And even use of data, arbitrary use of data, is deemed data science. So basically, there are so many terms to get lost in. Data analytics and data analysis. By the way, analytics and analysis are also used differently. And data engineering and statistics. So those are all very similar yet distinct terms. And is there a way to reconcile the definitions? That's the question that we asked ourselves, because lots of times people who come to our webinars and want to become our students think that our program is a program in data science. That is not quite correct. Our program is Master of Data Network Analytics, and no data scientist is not a data analyst who lives in San Francisco, all right? So, but we are going to try to reconcile these definitions. So having seen this question on Quora, I wanted to share with you the news of an upcoming webinar. Where do you want your data scientist career to go? It's scheduled for July 6th, and we're going to answer questions from a definitional perspective and from the perspective of what can a program in either data science or data analytics or teach you, or what's the difference? Is this job for you? Because lots of people who go into data science actually find themselves disappointed if they go into more of a computer science type of a program. And we're going to talk about the difference between those programs, what you will learn, and how to find the right program for you with this large number of different definitions and programs that are completely different, but call themselves using similar terms. So that's the webinar on July 6th. And if you post the link for everyone to register, and if you do me a favor and register right now, I would be delighted to see you all there. But I think between Norris and I, we have sufficiently filled in the pause to get our audience back in. So talking about how you can stand out, I think one way to stand out, no matter the field, data science, data analytics, statistics, is to do time series analysis. As I said, it is one of my most favorite topics. So today we'll talk about who we are, and I will introduce myself for those who are not familiar with us yet and the program. Then we'll talk about time as the ultimate independent variable. Those of you who are social scientists know that we have independent variables and dependent variables, and sometimes they can be used interchangeably. With some questions, as Nora said, you have to ask the right question. With some question, one variable, let's say job satisfaction, can be independent. With the other questions, it can be dependent. Well, time can never be a dependent variable, ever. Okay, it's just an axiom. I can prove it to you. I won't do it right now, but we'll talk about why it is the ultimate independent variable. Then I will talk about the effect of time, the stories and that talk about what time is. Some of them are simple, some of them are complicated. We're going to try to ask and answer some questions with those stories. Then we'll talk about forecasts. The one thing that will make you stand out, no matter what you do, no matter in what field, is ability to build accurate forecasts. And there are not a whole lot of people out there who can do that. It's interesting because there are lots of different help guides about how to build forecasts, but not very many accurate forecasts. We'll talk about why, and we'll talk about the power of time series. And then we'll talk about the power of our program, because we are one of the few master's level programs that I'm aware of that are not statistical, mathematical data analytic programs that teach time series on the level that we teach it at. So I will talk about what's the traditional approach to teaching time series is, and that's usually a reminder of its extensions. Many of you have heard about it, I'm sure. And then we'll talk about how we teach time series and why we do it that way. So let's start with introductions. I will be brief because many of you already have seen my face a few times. So as we talked last time, I'm a head of International Laboratory for Applied Network Research, but I define myself somewhat differently as a social data and network scientist. I think in this day and age, another way to stand out is to do interdisciplinary research. And data analysis is one of the few truly interdisciplinary fields. If you learn the tools, you can play in anyone's sandbox. And this is what makes this profession so valuable and so rare, because you can be a computer scientist, but it's highly unlikely that you will work, let's say, with linguistics or philology or law. I mean, you can program something for them, but not integrate. As data analyst, you can. But I will leave that for June 6th webinar. I'm the founder of Applied Statistics with Network Analysis Master's Program, and currently an academic supervisor of the Master of Data and Network Analytics Program. Now, for those of you who are wondering what is the difference, the Master of Applied Statistics with Network Analysis Program, we call it MASNA. It's the first program that our laboratory has founded, and it was the first program of its kind in Russia, where we used applied approach to data analysis, where we started with the problem and the question, and then figuring out how do you use available tools and available data to answer the question. Now, Master of Data Network Analytics, MDNA, is an online mirror that is offered on Coursera platform. The courses, professors, contents are very similar. There are not a whole lot of differences, except, of course, you attend classes offline here in Moscow campus if you're a master student, and you attend classes online via Coursera platform if you're elsewhere. Now, you can visit Moscow because you will be a full-time HSE student, no questions asked. You will be able to attend our events, our graduation ceremony, if you so choose, but you can do this at the comfort of your own home. So most of what I will be talking about today will be, of course, about the online program. Now, I want to say that our program is looking ahead. Again, the time series approach, proactive, notice the dates. I've actually never really, I've showed you this graph before, but I have never paid attention at the dates. So right now we are somewhere in the year 2021. We're looking ahead. This is called forecasting. Notice that this relationship is not linear. In fact, it's increasing at an increasing rate. And this particular forecast is built on many different data points. We'll talk about why this is important. The master program is, everything we do is offered in English. Both of our programs are fully English taught. So an important point about what Norris had to say is that network analytics is one of those fields of data analysis that is growing faster than data analytics in general. And data analytics in general is growing faster than data science, but we'll talk about that on June 6th. So what will you do in this program? Well, first of all, it's applied data and analytics. Why do we call it applied data? Because data come in many forms. You can have simulated data, which means you generate it yourself using random number generator, and the methods of analysis that you learn in your program will work just fine. But simulated data, even if you try to predict many different or build in many different problems into it, will never be the same as real life data, because real life data sometimes shows you things that you could never expect. And then, of course, to the traditional applied approach where we work with real problems and real data, we add state-of-the-art analytics and specifically network tools that, again, make you stand out from the competition, because there are very few programs in the world, and you can Google this, very few programs in the world that systematically teach network analysis. During your studies, you will learn to formulate questions. Every single method we teach starts with theory. Then we learn to take a complex approach to problems, formulate the problem in such a way that we can have what is called 360-degree view of data. We can look at it from different standpoints. You will learn a variety of different software. Even today, I will show you 3 different examples built with R, Excel, and Stata. So it's very easy to switch between different programs that we have. And using the mathematics, even though the mathematics remains in the background, we don't make you prove theorems, we don't make you memorize formulas. Computers do that a lot better than we do. We teach you how to interpret the output of the computer programs. Mathematics comes later, especially for those who want it. And then, of course, we practice a lot. There are a lot of practical problems. We have a consulting center. We have a student consulting center called Analytic Workshop, and you will have a chance to participate in real life projects on both on both levels. Now, we know that your needs are unique. Therefore, our program is very flexible. All courses are built on 2 levels. There is an intro to the topic, let's say introduction to time series analysis, and then there is advanced time series analysis, a more advanced approach. So if you have had time series analysis in the past and you know what ARIMA stands for, you don't need the first course, you can move on to the second. Now, if you want to take both, you can, or you can just stay with a basic course, have a basic understanding, but then take, let's say, stochastic data analysis instead, even though time series, of course, is a special case of stochastic. Now, what you can do with this education, you can win competitions. We had, check out our webinars, because we had our team who won 4 international competitions with a total prize fund of about $70,000. Our core faculty comes from all over the world. As I often say, our program is the best international education you can get without ever leaving Russia. As you have guessed when Nora said hello from Boise, my undergraduate and MBA degrees are from Boise State University. In our business program, I remember 2 professors who were really good. Norris was one of them. And the rest of them, I don't even remember the names. And it will be very common with many programs. You come to university and you will have 1, 2, maybe 3 stars. The rest will be young assistant professors, people mid-career, maybe some practitioners who teach you, but there won't be a whole lot of stars. What have we done? We have invited people who are the best in their field to teach in our program. So we bring you the best from different universities all over the world. And that makes your education very different than what you can get elsewhere. And of course, we have a menu of courses. You can start from scratch. You can take more advanced levels, as I have already told you, and you can choose the topics. Our topics are not limited to a specific curriculum as what's usually done at many other programs. All right, you can get more info at hsc.ru ENMA Data Analytics, and Anna will post this link for you in the chat so you can copy it. Do me a favor, click on that and check it out, just to see, because I want you to compare. I want you to know what it is that we're doing. If you become interested, we have a completely free network analytics for business specialization offered on Coursera platform. And this specialization consists of 4 courses. The first course is Contemporary Data Analysis, Survey and Best Practices, where we review what's out there in the field. What are all the methods that are available that can become available to you should you become a data analyst? Then, of course, there is a course in network analysis, but this particular course is done with emphasis on business. So people who are working in business right now can take the tools that we teach and apply them to solve real life business problems. Then we're doing text mining. Text mining is just like network was just upcoming and growing a couple years ago, and now it's a really hot tool. Text mining is getting there because texts contain so much information. We express ourselves much better with words than we are with numbers. So people who master text analysis are going to be ahead of the competition for a long time. So again, another way for you to stand out in that field. And this course is unique because it offers you text mining in R. You can find lots of text mining in Python, and all of those algorithms are very similar. There is nothing wrong with Python, except R is language for statistical computing, so you can build in some of that analysis into your other analysis in R, which cannot yet be done in Python. And of course, the business analytics, that is the diversity of practical applications that can be utilized at any real-life company. Which tools you can use to answer which particular question. This is the link to the specialization. Again, it's completely free. You can take the courses. If you want a certificate, I think it costs $49, but if you don't, you can just take the courses, and Anna will post this link for you as well. Now we are moving to time, and it is the ultimate independent variable. I'm sorry. As I said, for one particular reason, we can never affect time. Time affects us, not the other way around. And in that regard, I want to show you something that Anna has shown you at one point in time. This is actually Pew Research, and the topic of Pew Research, the number of environmental agreements that countries signed starting from 1850s. And I'm sure you have seen these on similar charts many times. Let's say evaluating the cost of the brand or talking about the wealth of people. Well, this is descriptive time series analysis because we are taking time and we are looking at, in this case, one variable, but many cases, we're looking at that one variable. How did it change over time for a particular country? And it's a cute example, but it allows people to understand that time is important. So we're coming back to our presentation. And let's talk about some examples that we have. And did somebody have a question?
Yes, Norris is holding his hand.
Yeah, Norris.
One of the things is that I wanted to echo I just started to put it in the chat, but what you said about having great faculty, one of the things that as I was researching your program is, in the programming world, they say an A programmer is worth 10 times a B programmer. The same is true with faculty, and memorable doesn't equal brilliant, but you've got a lot of A's on your faculty list. I mean, these are people that if you're going to take a course like this, take it from the best.
Exactly.
And I think that's really, I was looking at it. We won't name names, but I looked at a data science program a month or so ago at a prestigious U.S. university, and I couldn't even find. I mean, I don't know where they got their faculty from. It was kind of a little frightening. Maybe they're really good, but I just don't know about them. But you have assembled a remarkable team. And
Absolutely.
I think anybody who's considering that program is, you've got people who are renowned and competent. You can be very famous without being very good, unfortunately. Just look at Hollywood. But that it's very important. I mean, that's a big selling point. It's not just the topics. Anyway, I just wanted to, I was putting that in the chat, and and we need to get back to what I'm really interested in, which is time series.
All right, let's talk about time series.
Box check-ins for the win.
Okay, all right. So let's talk about time. Now, we use time all the time without probably realizing that. And one way that we use it is, for example, COVID right now, not the good topic, but time series analysis is used constantly. We are looking at the dates. This is starting from January 24, 2020. So that's when we started keeping track of all of those cases, when the world started to get scared about COVID. This is today, okay? And everything that happened in between is time. So looking at this graph, we can actually decipher a lot of information of what has happened over time. Now, I won't be asking questions, so I don't have to spend a lot of time, but what I was planning to actually ask is to see if you can see the straight linear upwards, what we call a trend. So this is a linear trend. So if you draw a line, you can clearly see that there was some increases. Now, this line, actually, if you remove these two peaks, this line is relatively straight. I mean, it goes like this, right? So from about 0 to about 400,000. It's these two bumps that generate a lot of problems. Now, these particular bumps, right? Those are cycles, and that's some kind of a cyclical pattern that we can analyze and take into account. So we have those trends, we have those peaks, we have some valleys. Now, of course, the confirmed cases, this is 7-day rolling average. So at this point, the COVID cases are still growing. It's still not on the downtrend. Do you see that? Okay, so we can use this information to see how far will it possibly stretch out into the future, taking into account the number of immunizations, the number of people who have gotten sick, the number of people who have recovered. But notice that we start with very basic analysis of the time, how much the data have changed over time. Now, of course, there are lots of other time-related comparisons, such as income, inflation, growth of everything, including, little children when they grow bigger, and our hopefully incomes as we get older, right? So now, why do we analyze data over time? And remember that question that I asked at the beginning, how do you set yourself apart? All right, so why do we analyze it? Well, to compare. We always compare, and with COVID, there are lots of comparisons going on from country to country, from one place in the country to another, from between age groups, between genders, between different categories of people. So we do lots of comparisons, and time allows that. Now, the next one is explanations. We can look back. we can look at all the variables and we can explain what has happened. Now, one of my favorites in social sciences is cause-effect relationships. Now, lots of people mistake causality with correlation. And I won't talk about spurious correlations. I think I've showed it to you if you've been to my webinars before, when you can correlate the pounds of margarine eaten with number of movies that Richard Gere appeared in, or something silly like that. There is a very famous website, tylervigen.com, that shows those spurious correlations. But cause-effect relationships can be established with time data only. Okay, there are no exceptions to this. And it's very important that time allows us to see the data from point A to point B and figure out what is the cause and what is the effect. Is it the chicken or the egg that showed up first? And extending that cause effect into the future is forecasts. So forecasts is one way that you can really make yourself stand apart from others. Because like I said, lots of people talk about forecasts, not very many people can do a good job of it. And let's talk about some stories, okay? And I will show you the stories that use the time, and then we can see how time affects our perception of what is going on. So here is a well-known story. This is the United States and USSR and, well, Russia's nuclear race. Now, some of you may have heard about it, some of you may have read about it, and it's one of those stories with some economists call it the prisoner's dilemma, because none of the sides were trusting the others to not attack first, so they were stockpiling the nuclear arsenal in order to prevent the other side from attacking. So here is, they just sending arrows at each other while stockpiling all of those weapons of mass destruction. And the caption says, on no account to be used because enemy might retaliate. Okay, so here's that story, right? So question for you, what do you think? Did we have a nuclear arms race or did we not? Did the countries escalate against each other or did they not? What do you think? Well, just looking at my face, you probably know it's a tricky question, right? Let's look at that. I'm going to use Stata as the program. Now that you have been to our webinars quite a bit, you probably know that I use different tools for different purposes, and Stata is the best for time series analysis. There is also eViews, but it's better for financial analysis and does very good ARIMA and dynamic link modeling, but doesn't have as much as many advanced features as Stata does, and doesn't have nearly as many packages. So Stata does very complex time series models with very simple commands. So I'm going to use this US-USSR data set, and I'm going to do just a quick few things. All right, so we have time series data. There is only 4 variables. We have a year from 1967 to 1988, and we have spending US and USSR in dollars. For that particular year, let's look at what was happening. I'm going to, well, the command is called tsline, don't mind me doing this. I'm going to look at US spending and USSR spending at the same time. So did we have a nuclear race or did we not have a nuclear arms race in terms of spending? Somebody talk to me. What's going on here? So these are the spending, I think, in millions, maybe billions of dollars. I don't know which unit, probably billions. And this is the time. So do we have it? Yes or no?
Well, we can at least say that they followed a similar pattern.
All right. So we have now, I mean, if you're concerned, right? So I have to say something. Again, Norris, you're not being fair. You're a professor, you know all the answers. So it looks like a race, right? And if you, I mean, any reasonable person. And I'm saying, Mark, you do not give it away. It's co-integrated relationship. That's correct. All right. So any reasonable person who looks at this graph, who has not studied time series analysis, would say that there is an obvious linear trend. Okay. As time was going on, each country was spending more and more on arms, on nuclear arms. At first, it was the US, they're in blue. They were spending more than the USSR. Then USSR has picked up. US was spending less. Then they were again co-integrated, as Mark said, but they were moving up, right? There is obviously, I already said this term, linear trend, upward linear trend at actually a very high rate, right? You can see that. So that is if you don't know time series analysis. Why do I say that? Because time itself is a variable and it affects many things. So just if you think about it, inflation, right? The value of money changes over time. What you could buy for $1 10, 20 years ago, you cannot buy today. Well, with rubles, it's a different story. I'll show that to you next. But obviously, things change just because time goes. The number of democracies in the world, that has increased, right? So has the number of military conflicts because people develop more and more weapons of destruction. So I'm sure that millions of years ago, people still fought with each other, but probably not on the scale that we fight with each other today. So things increase simply because of time. Now, how do we remove time from this? So we have to kind of, remove the time from equation to see what was happening between these two countries. Well, time series course teaches you that we do a simple regression. We regress each variable on time. And to remove the linear trend, we regress on a year, and then we create the residuals. So once we remove the year from the variable, what is left is the variable itself, right? So once we remove the effect of time. So we're going to call this US res. And then we're going to do the same for the USSR. Those of you who know statistics well, notice how high of an R-square we have. We have over 90% for one variable and over 80% of explained variance, but that's not really relevant. All right, so I have removed the effect of time. Let's look at these variables now. When I say I remove the effect of time, I remove the linear effect of time. What do it say now? Did we have a nuclear race? What do you see now? Talk to me. Don't be shy. It's another tricky question, right? Because you're saying, well, it looks like we have this decreasing and then increasing rate, and it looks like a parabola. It looks a U-shaped relationship, right? Well, we know that U-shaped relationships describe what is called squared variable. When we take a square of the year, well, the variable itself, of course, is not square, just the pattern that it follows is square. So what we have to do is we have to now remove the square trend of time, because time has this effect. So see, it was decreasing actually from 65 to about 80. They were not increasing their spending. Looks like they were decreasing and then they started increasing again. So, okay, let's look at this. Let's do regression on the year and year squared. And these are detrended completely for the time. And what do you see now? So this relationship remains co-integrated, okay? So we will not talk about co-integration, it's a different term. But looks like to me that except for a short peak between 80 and 85, all the increases that we saw are due to the time alone. And I can probably do some more analysis to see exactly how the time has affected it. Is this a structural break of some kind? That's another time series term. But overall, if you look at this, it appears that the spending on nuclear racing after we take the effect of time into account, kind of remained halfway flat. So that's the story here. And the story is very, very different than the story I have showed you first, right? So when we looked at this TS line, when it looked like it was a straight up shot and that the spending was increasing, yes, it was, but it was the effect of time, okay? The rest of the analysis, of course, is a little bit more advanced. We won't talk about it now. Let's move to another story. The ruble exchange rate, not so known, okay? And I'm not really sure if you're that interested in whether or not ruble is an interesting part of for your whether this is something I should really spend a lot of time on, because we live in Russia and rubles are important to us, but for people who live outside, it's not that important. But of course, here we are living in Russia, we want to know, well, is this a good time to invest in foreign currency or not? And the question is Russian economy resource dependent? Everybody says Russia is resource-driven economy. We sell lots of oil and gas, and that's how we fuel a big portion of our economy. So this is time. This is about 3,000 daily observations. I will show you very, very quickly how careful you should be about any kind of a time series analysis, because again, any reasonable person who has not studied time series will say that there is a clear upward trend. Well, there is a clear upward trend. I mean, I don't know how else to describe it, but the story, of course, is not really that simple. So let me show it to you real quick, I promise, just to show you that the relationship between ruble and oil is not that straightforward, okay? And you actually have to be careful and you have to take time into account. So we have daily observations, and then we have this TS line. I already showed you what the ruble per USD looked like. I'm going to show it to you against the price of Brent oil. What do you say now? This is Brent oil, and this is the ruble to dollar exchange rate. Okay, so there were some wild variations up until a certain point. This is about the year 2013, 2014, when ruble was not affected by the price of oil at all. Okay, and I have shown you also something that looked like an increasing exchange rate without the effect of time. Again, see how it has this upward trend. Let me show you what it looks like without this upward trend. Does it look like an upward trend now? Okay. So it's interesting when you start removing the effect of time from the data look very, very different. So time, that's the ultimate independent variable, has some wild effects on what is happening with our data. And without taking into account these wild effects, we might make wrong forecasts. And that's what I'm going to talk about next, unless you have questions. Ask me questions before I move on, if you have any. So the idea was to show you that time is important and it plays tricks on us more than we can predict. Okay? No questions. All right. Well, you can write to us later, and then I will show you some of the other things that we're going to do. So let's talk about forecasts. That's really the tool to leapfrog the competition. If you learn to build accurate forecasts, you can really take the market by the storm, because there are very few people that can carefully take all the effects of time and other independent variables into account, because they know how to ask the right question. So what Norris has said, and that, we didn't plan this. I mean, I could not have planned this better, is you have to ask the right question and you have to put this into the right context in order to get the result that you want. Simply programming a command, you saw how quickly I programmed something. It becomes your second nature very quickly, but looking for that essence of the meaning is what we teach in our program. And that is something that very few people out there in the market can really do. I'm absolutely serious. Just look at the accuracy of forecasts that are out there, starting with the weather. And then you will know all about it, right? So this is the Russian automotive market forecast. This is something that we have done as a project commissioned by Volkswagen Group Rus. We're coming out of the NDA with them, so I can show you this graph. So what we have found is that Russian automotive market, believe it or not, is tied very much to the economic and political cycles. Not only the data are very much seasonal, right? So here's a component that's called seasonal. There are very clear peaks at certain times of the year and very clear valleys. These valleys correspond to January. It so happens that in Russia, with the first 10 days of the year, we have holidays where everything is closed, nobody buys cars, plus it's middle of the winter and it's cold, okay? Right now we're complaining it's 90 degrees Fahrenheit, 35 Celsius out there. It's cold in the winter. So those are valleys. And then of course we have peaks in the summer. So this is a seasonal component, which is also the effect of time. But there is also a very clear cyclical component. And now we have more data. I can't show it to you, but we have more data that shows that our 60-month cycle that we have found in the data is actually accurate. I won't talk about that in a whole lot of detail, but what's important to realize is that market as large and as expensive as automotive market very much reflects what's going on in the entire economy and in the entire political situation. So you can't dismiss the elections that are happening. You can't dismiss the changes of the president, the economic crisis, some other things that are happening. You have to take those into account. And it was a lot of work, and we did utilize neural network modeling, but we also analyzed a lot of data and asked a lot of questions. So I want to share with you is the actual sales and the forecast that we built. So here is about March, where we have started doing our forecasts. We have submitted our forecast to the company in the month of June for July going forward. This is from the presentation we did to their management. That was in October of the year 2018. So you can see that the forecast was in this, I think it's dark purple color, and then the actual sales were in gray. Look at the numbers, right? We have actual sales in hundreds of thousands, 132,000 something, 136,000. This is our forecast. Look at the difference. Of course, the largest difference is the first month because that's when the model is still being calibrated. But then it kind of settles in on a very comfortable level. We have a difference of 36 cars out of 146,000. Okay, so that is the accuracy of forecast. It was accurate to 99.3% going forward to about a year. And I want to show you the tool that you can build with this. This is the tool that we have delivered to the company. It's built in Excel. So there is nothing, of course, too complicated about this. We have the control form that allows you to create the type of market you want to do. I'll just take the whole market, let's say the total market, and then let's say realistic scenario. Everything else here is optional. We'll do 3-year actual monthly series. And when we load the forecast, we get the actual forecast, realistic for the market total. And then we have, see, this is a year 2018 going forward. Now, this was done 3 years ago. And notice how for the total market, we never saw this peak. The company was questioning why this is happening. Now, I don't know how we picked it up so well. I mean, of course, we couldn't predict the COVID over here, but notice how this data are somewhat not really behaving very well. Guess what? Our forecast made 3 years ago is still within the bounds of our prediction of what has happened in the year 2020 with COVID. When the company called us and said, well, you know, will we get any sales at all? Everything is closed. Can you quickly calculate? So last March, I threw some numbers in and they could not, with the model that they had, dropped below 1.4 million for the year. And of course, they thought that the data was just completely wrong. Guess what? It was around 1.4 million, just a little bit higher than that. So the model was correct and it held through COVID. Okay. Now, you can, of course, look at different segments. So I can do this market segment. I can do PC market, which is personal vehicles. And let's say to do the premium, we'll still do realistic scenario. Everything else remains the same. And here's our premium market. I want to show you the premium because premium grows. Premium expensive cars that people pay premium for comfort, for safety on the road. It grew in our forecast, it grew through COVID. Again, we were very close 3 years ago to what is happening with the market now, okay? So if you can learn to master forecasting, and we teach that in our program, of course, you will be able to, again, leapfrog your competition. So the last thing I want to talk about is beyond the RIMA, the power of Master of Data and Network Analytics and what we can teach you in this program. So most traditional programs teach what is called dynamic linear modeling. It sounds really complex and complicated, even though it's just a RIMA. Autoregressive integrated moving average with some extensions. There is our FEMA, there is our MOX. I mean, there are different names, but it's all pretty much the same. There is an autoregressive component, which means data from the past, the values of the dependent variable, let's say sales, automotive sales from the past, affect the current values. And then there is moving average, which is moving averages of errors because there is some variation there that we can't predict, but we know that there is some function in those residuals that we get, or the difference between the actual and predicted. And they teach different extensions, and then it looks very complicated. So sometimes when you open consulting agency website, they will say, well, we use the newest tools of dynamic linear modeling. Well, that's a RIMA, okay? So there's nothing too big to that. But we take a different approach to that, much more involved, because we realize that life cannot be reduced to a single dependent variable, right? We have lots of things going on, and having just one variable, one dependent variable will not explain the complex relationship between the USSR and the US nuclear arms race, right? They were affecting each other. That's the co-integration. And so vector autoregression, when you can have more than one dependent variable, basically all those variables in the model are dependent and affecting each other. That's where our advanced course starts. So our basic time series course teaches the basic approaches to time analysis up to RIMA. Our advanced time course starts with, wait a minute, we have more than one dependent variable. Let's analyze them, because time allows us to do that. Having observations over time allows to do that. So we'll talk about vector autoregression, and then extension of the moving averages, the vector error correction model, then state space models, and some extensions to structural equations model, dynamic factor models. We talk about Bayesian a little bit, time series for count data. Count data are very special because they're truncated at 0 on one hand, and of course you don't have the continuous scale. So typically you analyze count data using some kind of categorical data analysis techniques, but categorical data analysis techniques are not really that advanced, right? They can't extend to time series. So count data for time series is a special class of models. Then, of course, there's some more stochastic approaches such as Markov switching and change point methods, and of course, a large variety of forecasting tools, including neural networks. Now, neural networks are not my favorite. The problem is that, yes, you can tweak them a little bit, but still at the end of the day, you don't have a good understanding of what's going on. So I had to do post-processing for some neural networks to build that forecast where you have a difference of 36 units out of 130 something thousand, okay? So, and we can allow you to learn all of those tools and not only learn them, but practice them. Because from what I see, there is a lot of need in the market for this type of advanced analysis. And the main problem with this approach is that not that you don't know the tools, anybody can learn the tools. There's lots of information. Google any of these names, and you will get step-by-step instructions of how to do that. So we are teaching beyond the how. Anybody can teach you how to do that. those Googling algorithms, they will teach you how to do them. Knowing when to use the right model and how to combine models, how, for example, to apply filters first and clear some of the noise out of the data, and then use some kind of forecasting tool, or how to use filters for forecasting. Where is that choice? How do you make that choice? We teach that in our program, and that will set you apart from everyone else. So the essence of setting yourself up apart, and the essence of excellent forecasts, is understanding how time series works. So do me a favor, click on those links that Anna has given you in the chat and check out what we have to offer. We have just about a month, just over a month left to apply to our program, and we have lots of discounts that we're giving to people based on where they are from. So our discounts are up to 50% of the cost of the program. So please go ahead and join us, and we'll be happy to have you. But of course, wait until next week so I can tell you if this program is for you. Remove the effect of time. Oh, excellent question. Thank you, Fernando. So what do I mean by removing the effect of time? We are removing the variance in the data that can be explained simply by time passing from one point to another. So you know how inflation makes our money less and less valuable every year. What you can buy for $10,000 today, you can't buy 10 years from now, 20 years from now. When Professor Wasserman was talking to us about time series, he said, I bought my first house for $12,500. Now, can anybody buy a house for $12,500 now? No, that means that the value of money has decreased because of time. So inflation has happened, some other things have happened, maybe economic crisis. But to find what that effect of time was, and why do we want to remove that effect of time? Because if Professor Wasserman could buy a house for $12,500, then somebody else could also, right? So we are all affected by that time-related change about equally. My dollar is not worth more than yours. So our dollars are worth the same. So if they're worth the same today, then they were worth the same some time ago. And by comparing these values some time ago and today, we can tell what happened to that purchasing power, right? And we can do that by removing that effect of time. What I'm saying, removing is regressing our money on time and removing the variance that's explained by time. Did I answer your question? Thank you. And Fernando asked to share the links again. If you would, that would be wonderful. Any other questions? To what extent the program provides the opportunity to use computer simulation tools? So simulation is a part of most of our courses. I start even the simplest course, which is the review course, as I call it, contemporary data analysis, with some simulated data where I teach how to simulate the data and how to remove some of the data to see the effects of missing data, right? So when we do missing data analysis, we do it on simulated data. So most of the courses will rely on some sort of simulations. Networks will certainly do that because most of the modeling in network analysis is built on simulations. Bayesian methods do that. Stochastic methods do that. So if you are talking about using computer simulations as an approach to analysis, that's part of almost every course. I think that maybe, no, even the applied linear models, the very basic course that we teach uses simulation modeling when we start talking about machine learning. I mean, machine learning was first introduced for regression, so there are some simulations that are going on there. So there is a lot of simulation modeling going on in also being used in lots of different applications. For example, right now, one of our students who just finished the program. She had a brilliant paper on fraud in elections. She's going to now try to verify her results with simulation modeling. So it's a standard tool. It's used a lot. Time series course only available to master's students. Can someone take only one course online if unable to participate in the entire degree program? Now, I have to find out, because somebody else already asked me this question. I have to find out if master's courses can be taken on Coursera separately in our offline program. If you want to enroll into only one course, you can do this with offline program, but participate online. So this is a course that's happening live, and you just connect online. We had some students who do that this year, obviously because of the COVID, but otherwise courses in the offline master's program are open for individual enrollment. Any other questions? Thanks, you guys. You're always very very responsive audience. It's fun to talk to. I want to again extend my thanks to you for joining us today, and especially, Norris, to you for joining us and being a part of our webinar, which was completely unplanned and a very big surprise, very pleasant surprise. There are 4 courses shown on the page that the link points to. If it's a time series course, then it will say time series. So we have probably the courses that are open for enrollment at a certain point in time, because you have to join the class when it's offered. The time series course just finished. So, but you can write to us. Please write to either Masna at HSE or MDNA at HSE. I will show you again their email, and we will get in touch with you and let you know how you can take individual courses. Is the occurrence of business cycles in the economy application of time series? Of course, yes. Business cycles are irregular cycles that you can build a function for and then remove that effect of a business cycle from your data. And for business analytics, you have to do that, because otherwise some of the ups and downs that happen because of the time will be incorrectly attributed to some independent variables. And yeah, Marcus, I'm trying not to use any of the big terms, not to scare people. And he is here throwing co-integration, Hodrick-Prescott filter. Yeah. So yes, there are lots of different things that you can do with data, including removing the filters. And there are many different filters out there. We have a whole series of lectures in filtering where we explain which filter does what. We can remove the business cycles. You guys were great. Thank you for all the questions. And I think we have taken just about an hour. So please check out our specialization. Join our Telegram chat. It is for applicants to our program, but you can ask questions without being an applicant. And stay in touch and come back in a week so we can talk about the difference between data analytics and data science and figure out which is the one that is best for you. Even if it's not our program, we want you to enroll into courses that will advance your career. Remember, in the language of math, our motto is be greater than average. Yes, there is a recording. We will post the recording. We'll send a link to it to everyone. And I want to thank again Anna and Grigori, my tireless assistants that have been with me this past 6 months through all of these webinars. All right. Thanks, everyone. Goodbye.
Thank you. Goodbye.
Goodbye, everyone.